Hi, I will be helping you today in finding the axis of symmetry in a parabola when a current I flows through a given electrical circuit. The power W of the circuit can be determined by the formula W equals, let me write it down here, 120L minus 12L squared. What amount of current L supplies the maximum power W? Let's convert this one to x-axis to x and y. We know the variable by itself is always y equals 120 x minus 12 x squared. We don't have to convert it, but this one looks more familiar to us than this equation here. This is you need to find what amount of current I, what amount of current X supplies the maximum power W, supplies the maximum Y. What value of X can make the Y maximum, can make get the Y to the maximum. Okay, we're looking for, let me sketch it here. We're looking for a parabola because you have x squared and x. You're looking for a parabola like this. Where is let me just do that. Where is the maximum here? This is the x and this is the y. You're looking for after how many x's the y reaches the maximum, its maximum. And we know this function is going to be, it's going to be open downward because there's a maximum, because there is a negative coefficient for x squared. All right, to find after how many points, so that's, we call it the axis of symmetry. And there is a formula for the axis of symmetry, which is negative b over 2a. What is b? First of all, what's a? A is the coefficient of the x squared, the number beside x squared, negative 12. And b is the number beside x. b equals 120. Substitute, so that's going to be negative 12, negative b over 2 times a. b is 120 and a is negative 12. That's going to be, with your calculator, negative 120 divided by 2 times negative 12 is negative 24. How about if you decide not to multiply it and you multiply it in the calculator, you must open a parenthesis to do that. 2 times negative 12. The final answer is 5. So after 5 seconds, or after 5, the amount of current I, so the amount of current X or amount of current I, which is 5, supplies the maximum power. This point here is 5, and this one supplies the maximum, gets to the maximum point. Choice C is the correct choice. Another way to do this problem is that you're going to type this equation in the calculator, 120, of course, X. Do not type L, the calculator doesn't know anything about the L. 12x to the power of 2. When you grab that, it's going to be out of bound. So you click zoom 0 or zoom fit. I see the maximum here. Press second trace to find the maximum. The max. Where is your left bound? Here's the left bound. Click enter. And then you move your cursor. Where is the right bound? You move your cursor to the right bound of the maximum, as we do here. As you can see, the cursor is here. Enter, and then go back to the maximum. Guess where is the maximum? Here's the maximum. The x-axis is 4.999, which is 5, and the y value is 300, which means like this point here is 300. Okay, but we're not looking for 300. We're looking for 5. Work well.